by Pavitra Subbaiah in 2021, that she proved that this pi of r value is positive, then only the instability region is lies within the parabola. Okay, but when you observe these two, we have got one improvement, that the condition is very small. If modulus of W minimum is more than 0, then only you can say the instability region is lies within the parabola that we said. Okay, and we have plotted the graph by taking the velocity per function sin r square. We have taken the sinusoidal flow, and r1 equal to 1, r2 equal to 2. Here we can observe that this is the same Bachelor-Gill semicircle. This is totally instable region which Bachelor-Gill got it, and this is what the parabola which we got. We are saying that the our parabola will intersect the Bachelor-Gill, and here we can observe that there is an improvement in the Bachelor-Gill, and whereas the Pavitra Subbaiah, they got it the parabola where it does not even intersecting the Bachelor-Gill. That is what the improvement we have done. Okay, and this graph indicates that for the different values of k, this instable region is going to decrease. This is for k equal to 0. We got it. Okay, now one more result we proved, that the verticity function, minimum value of verticity function is more than 0, then the CRCA values lies within the parabola. And this also we have compared with the Pavitra Subbaiah, and we got good results. Okay, compared to this existing. Now the one more improvement we have done here is that, okay, yeah, so in the previous results, the results are depends upon the condition, but here there is no such type of condition. Here means this result will applicable for all velocity profiles. Okay, so that is what the improvement we got. It means for unstable mode CA greater than 0, this is obvious. We have located the CRCA values in this plane, in this region, and we compared our result. We shown that our parabola is intersecting the Bachelor-Gill, and we have compared by taking the example sinusoidal flow, by taking R1 and R2 like this, and here we have plotted like this, and see our parabola, means our new result is intersecting the Bachelor-Gill semicircle, and see if you understand, this is the instable region which we got it, and this is the Pavitra Subbaiah. They proved that the instable region is lies within the parabola, and we reduce the instable region here. That is what the improvement we have done compared to the existing results. And this is the, for different values of k, the parabola is decreasing, means instable region is going to decrease. Okay, now this is the one more result we got it, and the same we have taken with a different velocity profile, and similarly we have shown that the instability region is completely reduced, and this is the stability. Okay, so this is the last one which we got it, and this is a better result compared to the all, and even our results also we compared, and this is the very narrow instability region, means we have shrinken more instability region compared to the existing and mine also. This also does not depends upon any condition. Okay, now that till now I discussed the results of instability. Now let us come to the stability. Now this is the criterion condition, that if k square value is more than kc square, then the flow is stable, you can say. If the k value is more than, in this case, where is kc square is this value. Okay, and how to compare whether our result is valid or not? There is existing result. Now here Pavitra Subbaiah, she got it in 2019 that k square is greater than kc square. Kc square value is given by this. So here we can observe that the complete term is same, but here we got this term is extra, means this value is more, means we got k value more, means we are saying that the stability region is increased compared to this, means instability region, oppositely instability region is decreased. Okay, so here we plotted the graph by taking the velocity profile, and we are saying that these are the stable and these are the unstable modes of the fluid flow for the different values of k, the different values of k. Okay, Yeah, this we got some of the more results. I'm not going to explain more all. Now let us come to the application part. Now there are many applications are there on circular relay problem and also heterogeneous differential equations within the within the two concentric cylinders. Now let me go through first one. Medical applications. It is given in Walton book, 1961. That before when I started, I told that thread injection cut. Right? The thread annular flow is a model to use to study the surgical techniques of thread injection of medical implants. Okay, and there are many applications in the aerospace and aerodynamics. Okay, now actually this problem will be applied to understand the airflow around the circular objects like airfoil, turbine blades, and also it helpful to analyze the diffractions of the air and other gases around the structures. And this will be very essential to predicting the drag, lift, and stability in aircraft and rocket designs also. Okay, and applications are there in the medical field, imaging and diagnostics also. Okay, and this problem will be very helpful to improve the image clarity of resolution in ultrasounds, MRI, and similar diagnostic technologies. We are not going to read deeply. The next one. Now, there are some applications in acoustics also. Now, our problem will help us to understand how the sound waves are affected when they encountered the obstacles like circular walls, speakers, grill, and other circular objects. Okay, and this will be helpful to interact pattern how sounds are disturbed in a room. Okay, and some of the applications are there in seismology also, because all those work depends upon the waves only, where the disturbance happens. Okay, and this is the main thing, electromagnetic wave propagation. Now problem is used to study how electromagnetic waves interact with the circular structures like antennas and cylinder objects. Okay, so actually our problem is more useful to uh, characterize and where it is actually useful to improve the signals. Okay, and also it will be more impact to get the clarity of the waves and strength of the waves. Okay, so this is my talk, and this is what there are two good examples which I can give you, but we are using the parameter R, but in other hydrodynamic stability they are using, instead of they're using the R, they are using the D term, diameter. So when you use instead of R, diameter, these two will be the very good examples, natural examples which we can give. And here you can say this is two-layer model, Rameshwaram and Mannar Strait, Bay of Bengal and the Indian Ocean, and one more three-layer model, Bab and Mandab Strait, Red Sea and Gulf of Aden. Okay, so these are here the fluid will be here, the narrow will come, means the fluid is flowing in a big density, big diameter, but when you come to this narrow part, how the flow is stable and where the instability will come. That is what these two examples you can say, natural examples. Okay, so with this I'm going to wind up, ma'am. So